Okay, so thank you. That's great. Okay, perfect. So thank you, everybody. I mean, the idea to have this workshop was just to give you an overview of what we're doing and how we can help you in order to publish some data. As, I mean, we are now getting to the point that OceanEye is producing data. And so this is a sort of brief recap of some of the ideas and the tools that we have been developing and deploying for the project. And then, of course, this, I mean, is not, let's say, a frontal presentation, but it would be, I mean, feel free to interrupt me and ask every time you want, because I'd like to be very interactive in this discussion. I'm going to share my screen. Yes, okay, should be like that. You see it? Yes, I guess so. And okay, so basically, I mean, we are going to, as anticipated, I'm going to give you a brief overview of some data management, let's say, concept recommendation, and how we are building also the data management plan. Then brief recap of how we are implementing the OceanEye data infrastructure, and then we can discuss about some metadata and standards that it's good to keep in mind for both near real-time and delayed mode data. One thing that is important to say that most of the concepts here are applicable to the in situ data. But we also have a couple of recommendations for models or for, I mean, remote sensing reprocessed data. So just we go through them, and then, as I said, anytime that you want to comment or add, you have a question, please feel free to interrupt me. So the data management plan, as we know, is a compulsory document and action that we have under the Horizon Europe, and it was designed, I mean, this, let's say, commitment, this recommendation was designed in order to support open science. The data management plan is an evolving document because for, I mean, the new projects, starting from actually since the end of the Horizon 2020, and for all the Horizon Europe project, the projects have to deliver at least 3 versions of the data management plan. One is due until 6 months from the start of the project, in which you outlines, I mean, somehow the general idea, so how the data is going to be collected and used. Then you have a second version that is more or less at half of the project. And then you have a last version that is at the end of the project. And so you can use also, I mean, somehow the data management plan is also used to keep track of all the, let's say, hypotheses and assumptions that you're doing in the project. And then you also use this document in order to, let's say, verify a proof that what you planned is exactly what you're doing. And then if you have to change something, because it happens that, I mean, technologies evolves, recommendation may evolve, stuff like that, you just report it. And then you can use it as a sort of KPI for the project itself. Let's say, ultimate goal of the data management plan is really to ensure the availability and the utility of the outcomes of the project research. And internally, I mean, for the project, the data management plan sets some of the, as I said, the recommendation and the constraints that you're going to develop for the data management in the project. And which are these kind of recommendation and constraint? So one basic requirements for the open science and from Horizon Europe is that each project has to deposit metadata and data as soon as possible. So after producing or generating any kind of assets, we need to inform the community that we are delivering data. So for example, for us is we have an easy example. As soon as we planned to deploy Argos, Pierre knows that, we already informed that this plan was already ready. And then we can keep track on that, because as soon the data is starting being available in the Global Data Assembly Center, we can also prove that the project is contributing to this knowledge. Then the data should be deposited into a trusted repository. Most of the Horizon Europe are recommending that these repositories should be federated to EOSC. EOSC is the European Open Science Cloud Community. And for example, most of the nodes that we know that are already managing the data, like the National Geographic Data Centers or Emonet, are somehow federated to EOSC, so they are trusted repositories as well. Then we have this strong recommendation and commitment from the Commission that data should be as open as possible. And of course, it could be as close as necessary, because in theory, we are supporting, I mean, especially for our project, we are supporting really long-term assessment. We are related to the climate change. So this kind of data are very valuable and so should be open. Of course, it doesn't mean that we need to publish as soon as we collect the data, because we always have to validate the data. We have some, I mean, activities also for the scientific validation that could be done. But by the end of the project, we need to deliver all this data. And of course, in order to make data as open as possible, we also need to implement fair metadata, and the metadata should be fully open. So people should know that we are doing a given research in a given place of the world. Then, of course, the Commission is also pushing for having an open license on top of the data. So European Commission is pushing for having a very well-known, let's say, vocabulary for the license. So they are encouraging to apply the common creative framework, and in particular the CC-BY. That means that we need to credit the authors, so you guys that are collecting data and the project, but then the data can be reused and broadcasted as much as possible. And then, of course, or we can also use the public domain license. But in our case, it's better to use the CC-BY because we also need to give credit to the project. And then, together with the data, of course, we are also encouraged to make available and accessible all the kind of documentation that can help other scientists to reproduce and and come to the same results with the data that we are doing. So if we are developing scripts, algorithms, softwares, it's good that we also publish them in a way that the community can use it. And of course, there are different means for doing this. GitHub is one of the many. So the data management in OceanEyes was designed in order, we stated that we were going to adopt open science practice. So we are committed to make our metadata and information fair, as fair as possible, and discoverable, et cetera, et cetera. We designed, I mean, the data management in order to enable the discovery and open access of the data, but also we were considering to make available some, for example, some code. At the time of the writing of the proposal, we said we may make available some Jupyter notebook that can be an example of how to consume the data that the project is making available or collecting. Then, of course, another commitment that we have is that we need to work in cooperation and collaboration with some key stakeholders for our project. And of course, I mean, the Southern Ocean Observing System, Emonet, and Copernicus are the three main stakeholders for us. And I have to say that we are doing quite well in collaboration with these stakeholders. And then, of course, for doing that, we need to implement and set up some practical tools that are helping us in this data management and federation of the activities. We were also planning to develop also some, let's say, more user-friendly tools in order to access the data. For example, MapViewer for data discovery and access. This is just to say, remind ourselves that, as you can see, all the project, I mean, all the work packages in the end are somehow dialoguing with the work package 7, that is a sort of hub or gateway of the data that the project is collecting and producing towards our stakeholders. And the table on the right is somehow mapping which kind of data are considered or used or produced under the different work packages. So most of the work packages that we are doing in Ocean Eyes are dealing a lot with the data. And then, of course, this is also important that we already said many times, but different type of data may follow different routes, because, for example, in case of the in situ data, we have nowadays that IMONET has been identified by the European Commission as the, let's say, main hub, the main European hub for in situ data. So we need to do any kind of effort in order to make the Ocean Eyes in situ data visible and federated into IMONET, sorry. While if we are producing or updating models, of course, they are not feeding, I mean, the scope of IMONET, so we have to find other routes in which this kind of information may be visible and available. And there are a couple of them. For example, in case of reprocessed satellite data, it's important to have an open dialogue with Copernicus, because that is the main repository, main European repository for that. And for model, we have now a new initiative. I will go back on that at the end of the, I mean, in the last slides. We have the Ocean Prediction DCC that is now mapping all the models that have been developed and dated at European level. And so it's important that we now also feed this kind of inventory. Going to the in situ data, that is, I would say, the main focus of, let's say, the data management and the infrastructure that we implemented. At the beginning of the project, we also designed this spreadsheet in the shared folder in order to keep track of what were going to be produced by the Ocean Eyes. I have to say that is not working that much, because I did this snapshot 3 days ago. I have no information. I mean, nobody is using. We neither using this kind of tool in order to share this kind of information. So we need to discuss also an easy way to exchange information and plannings. Now, before going back to the point now on how to exchange more information and better, just a brief recap of how we are implementing the backend data infrastructure of Ocean Eyes. We are building on top of what has been developed during the SOSHIC project. And during the SOSHIC project, we designed, let's say, this architecture that is composed by 3 logical layers, in which we have one layer that is more a data layer, in which we do all the, let's say, the machinery to connect the data and have this data in the project backend. Of course, this means that we federate nodes, or we help you to publish data, and then in the end, we keep track of the data that has been produced by the project in order to be sure that we can present them, and then we can also inform stakeholders that this new data has been produced that can be consumed. And then, of course, we need to mark this data as Ocean Eyes and SOSHIC data. Then we have a service layer in which we do more cataloging. So we are formatting, let's say, the data in a way that can be, let's say, published and consumed by machine-to-machine interfaces. So we are implementing a GeoNetwork catalog, AirDAP catalog, that are tools that, I mean, we already presented during some of the meetings, are standard, up-to-date tools that are managing the data and are facilitating interoperability. And then on top of this, we implement the application layer that is really the map viewer or other services that we can have in order to present and interact with the data that we are producing. So in the end, what we're doing, we are already deployed this kind of infrastructure. So here you can see that we have an AirDAP instance for managing the data of OceanEyes. This is the link to that. And by publishing data into this backend, into this catalog, then we can push, so we can make our data available to the stakeholder. For example, we can see some of the data from OceanEyes. We can already see some of the data of OceanEyes in the SWOOS map, and we can also play a bit with this data by implementing some of the open science tools that I was mentioning before. For example, here you have a couple of pictures of some Jupiler notebook that we wrote on top of the data collection that we are publishing on AirDAP. Of course, in order to do this, we need to standardize, harmonize a bit the metadata and the formats, because of course it's easier if you use some standards in doing this. And as Work Package 7, part of our job is to do this activity, so to help you in order to harmonize the metadata. These are some general recommendations, because of course, when we speak about metadata, we are speaking about a common language to let also the machine-to-machine interaction, and it is complementing the data with some key information about the location, the methodology, about how this data has been collected, some links to the quality, let's say methodology that has been applied to verify the quality of the data, and so on. I mean, who was involved in the collection, the calibration, the algorithms, and so on. So these are kind of information, but you know, this, the thing is that we need to keep track of that. This is not what we're doing, but this is a very nice example of how metadata can really support a nice discovery. And somehow the same metadata that we're using are making our data very accessible, not with this interface, but in a very similar way. So these are somehow the recommendation that we are pushing in OceanEyes and SOSHIC, but they are also adopted by SWOOS. So basically what we are suggesting, again, this is mainly for the in-situ data, is to adopt the NetCDF format, version 4, to apply the OceanSites data model, because it's very well known and adopted in the community. And these are some key, let's say, standards for implementing some of the metadata. For example, in case of the timing, it's good to use ISO 8601. For the datum, it's good to use WGS 84, to use the GCMT convention in order to express which is the property that we are collecting, adopting the British Oceanographic Data Center, the NERC vocabulary service for the description of the parameters, and so on. And then on top of this, we are also adopting and pushing some of the recommendation that has been, let's say, pushed by the GOOS, so the Global Ocean Observing System. And they are pushing quite a lot to implement AirDAP nodes, because in the end, AirDAP is really facilitating the interoperability and the harmonization of the different data standards. Then at the European level, we also need to keep in mind that we defined at the European level some specific vocabularies for some specific platforms. So for example, in case of Argo, EuroArgo is adopting the R03 convention, in which we have all the description of how to name the different parameters, so this, the standard names for the parameters. We also have the same for the gliders. For example, in gliders is OG1, that is Ocean Gliders 1 recommendation. Then going to the near real-time data, if it goes towards an international program, for example, Argo, metadata is available from OceanOps, because OceanOps is managing all the planning and the KPIs for the deployment of these systems. at the moment, the system is down because they are doing some major updates, so we cannot really harvest all the metadata from them, but usually it works. And data is published into the Global Data Assembly Center that for Europe is Coriolis, that is hosted at IFREMER. So as soon as the data is, as soon as the platform is deployed, actually we can see the data. But of course, we need to be informed about the WMO code that is assigned to that specific platform, because we don't know otherwise. We can check if the specific WMO code is published, but we need to have it, because we need to normalize some metadata that are coming with the platform, because sometimes, and we noted it actually often, that some information about the institution or the program that is supporting the specific deployment is not properly recorded in the metadata that are flowing together with the platform. And this is applying for all the, let's say, OceanOps and Goose networks. This is just to show. There is any question? Okay. It was just an echo. This is just to show you that in case of some of the Argo that has been deployed last year, as soon as we received the WMO code, we were able to identify them on this Global Data Assembly Center. So we were able to dump this information into OceanEye backend services. And then we were able to be sure that these data are visible into Emonet. So if you go to Emonet, for example, then if you select, the in situ platform, and then you filter by OceanEye as a program, as a project, okay, you cannot see really well the picture, but I can ensure this. You have OceanEye as a program, and then you see the platforms from OceanEye. And then if you click on top on those platforms, then you see that they are coming from OceanEye and also the institute that deployed the platforms. And of course, the same works, the same is for the SUS, because as soon as we have this data mapped, then we broadcast this information towards Emonet and SUSMAP. Then in SUSMAP, we also implemented an easier way to identify the OceanEye platforms, because we grouped them into a specific card, so you can easily see. I marked it in red. For delayed mode, then the, let's say, workflow is a sort of two steps approach, in which we suggest to send us some samples of the data that you may have collected, because in case of delayed mode, the approach is to publish the data into a trusted repository or in one of the national database together with the DOI, because then we can use the DOI in order to keep track of how many people are using or accessing this data. That is a kind of indicator that we can use then in order for our reporting purpose towards the Commission. So the first step, let's say the first loop, it's good that we work together so we can check the data, the format, the variables, so we can help you and you can help us in order to apply the conventions that I mentioned before. Then you can publish it into one of the trusted repository, or we can also help you to publish it in one of them. And then we can plug it into the OceanEye backend system. And then once it's published there, then we can also broadcast it into Emonet, SUS, Copernicus, and so on. Again, it's important for us to have information about the planning. So to collect the metadata of the plans as soon as possible, because starting from the metadata, then we can follow up on the process together with you, and then we can ensure that we speed up or we make very timely the publication of all the information, both in the OceanEye backend system and in the different, let's say, dissemination tools and ways that we need to use. In case of OceanEye, we have, some plans. Some are already ongoing. We also know that according, let's say, the country that is supporting that specific part of the research, we may have some national database that can already host or give the DOI to this delay mode data. I listed some of them. They could be also more, but the most important thing is that please keep us informed, because as soon as you're starting your process to deploy the data into one of the, let's say, the national database, we need to know, because I mean, we are federated to many, but if we don't get the information that new data is going into, then we cannot find it in the database, and then we cannot mirror in the, or link it into the OceanEyes backend. And then, of course, if you need any help for the formatting or for which kind of metadata you need to apply, complementary information, and so on, please feel free to ask us. I mean, we are here for that. Then the other thing is that if you want to speed up the process, you can also think about installing an RDAP node at your institute yourself. RDAP, as we said, it's a very powerful tool because it's somehow managing many issues of the data management, because it's it can manipulate many data formats. It is very good in mapping the metadata. Of course, you need to do some work in order to apply the proper convention, but it's quite powerful. It exposes data in different formats and by means of different tools. So stakeholders can easily implement interoperability if you have an RDAP node. And of course, we can also exploit some tools that are already available. For example, under modern physics, we deployed a Docker for supporting people that would like to install this technology at their premises. And so it is very easy. So you have this installation system that you just run it, and then you have the RDAP on. Of course, I mean, it's not that easy as I'm telling, because you need to be supported a bit in order to implement it. But we are supporting many institutes in doing this activity. And we saw that really in less than 1 month, you may have an operational RDAP node. That means that when you have finished collecting your data, then you can deploy your data at your premise. So we have not to move any data, and then we can federate directly the instance that is published from at your side. And we can implement virtual connection and virtual streaming directly from your institute. The other way to, let's say, commit delayed mode data is also making use of the Immonet ingestion tools or service. Again, Immonet has implemented this horizontal system in order to facilitate the, let's say, the delivery of delayed mode data towards the Immonet network. In this case, you have, let's say, a sort of wizard that you may follow in order to drop the data. And this can be very useful if you don't know how to get a DOI, because Immonet ingestion is federated with Sinoe, that is a French system that apply DOI. And so if you submit your data to Immonet ingestion, then you get back the DOI, and the dataset is published in both Immonet and Sinoe. So we get, I mean, as you can see here, you have a sort of very easy wizard approach. And then you have the collection published. And then, but also in this case, please let us know if you're doing this, or we can support you in doing this, because then we need to federate. I mean, we need to also synchronize the fact that this data is available in Sinoe or Immonet with the backend service of OceanEyes. So let's say the take-home message is please keep us informed about plans. And as soon as you start collecting or recovering data, because we can help, so we can be fast in publishing the data towards the OceanEyes system. You can use the work package 7 mailing list, or you can mail to me or my colleagues. So these are, I mean, these are the people that are working on this. Actually, there are also more than them, but you may find support. It's good if you send us file samples if you have any doubt, because then we can help. We can also play a bit with this data in order to see how to format it in CDF, which kind of convention we need to apply. If we need to ask for a new vocabulary, we can also do that. I didn't mention this, but we have a very good collaboration with the BODC in order to implement and update the vocabulary system. We need to use standards, so some I mentioned. It's also another one that is now the Commission is also pushing is to include also the ORCID for the researchers that are working in the for the the collection of the data, because then it will be easier to keep track of who was involved in for doing what, and this is helping us to give credit to Ocean Eyes. Then, of course, if we are speaking both for near real time and for delayed mode, we need to get the DOI for data, because then somehow it will be easier to keep track of the legacy of the project. And this is, of course, we need to think about this, and it's applicable to both the in-situ data, but also for the models and the other things that we are developing. Of course, if you think about paper, then it's easy because each paper is coming with a DOI, but also for the other things that are not really, let's say, papers per se, we need to have in mind to have this kind of digital identifier to keep track on that. Then concerning the map viewer or the way we can explore the data, we decided not to reinvent the wheel, but really to have a special, let's say, place in the SUSMAP. And as I already presented before, we have some dedicated cards for Ocean Eyes in which we are presenting the in-situ data. This is just a snapshot of the different kind of data layers that you may find in SUSMAP. But again, if we want to have something similar that is customized for Ocean Eyes, we can easily deploy it. It's not a problem. But more important is that we have a clear credit for the Ocean Eyes project in the SUSMAP. So this is a very important outcome and KPI for the project. Almost last but not least, as I said, lately, we are in the ocean of DECAD, you know. Most of us were in Barcelona a month ago, discussing about the importance of this DECAD. And within the DECAD, there are some collaborative centers and coordination offices that have been launched in order to support the different action that we can implement during the DECAD. Here I'm mentioning three main DCC that are quite important for us and for the project. The Ocean Observing, that is coordinated by IOC and GOOS, the office that is in Paris. The data sharing, again, is coordinated by IOC, the IODE, and the office in Brussels. And then we have the Ocean Prediction one that is coordinated by Mercator Ocean. These three are quite important because one is about, let's say, the remote sensing data and reprocessed data. One is about the models and one is about the in-situ data. So these three are somehow new stakeholders for our project. And we need to be sure that they get the proper information and we are well connected to them. For data sharing or Ocean Observing, I can tell you that we already are, because IMONET is somehow a federated node for that. For models, we have the Ocean Prediction one. And so, as I said, as models have, they are not in-situ data, of course, but if we are implementing, as we are updating some of the models, we are making new high-resolution models in a very specific area of the Antarctica, also Arctica, it's quite important to register this information. So some basic metadata about the models, the bounding, the scope, the resolution, and so on, in the atlas of the models that Ocean Prediction is doing. So this is the way to make sure that our outcome, the model outcomes are probably mapped also in a wider community. So this is also an important recommendation that we have to keep in mind and start doing. Also here, if you need help, let me know, because I'm somehow connected to these people, so we can help you out. And that was, I mean, the brief recap of the things. And so now open to discussion and question, anything you would like to to tell and discuss about. Yes, Andrew.
Thanks for that, Antonio. And as you were doing that, I was playing on Seuss Map and looking at the profiles that you put out, Pierre, that you were telling me about in front of Thwaite. So it's very, very cool. In terms of the data sets so I mean, obviously those have been those floats have been ingested from Arvi and from Bass. But the other observations that went on this last season were Anna Varlin's work with the AUV and Pete Davis's work deploying stuff underneath Thimbleson. Have you got any information from them yet?
Not that much. That's the problem. Because in this case, I mean, with Pierre, I mean, as soon as Pierre was planning the deployment, he told me, I mean, he sent me the list of the WMO code, so I was able to find them and connect them. But for the EUVs, I didn't receive any information, so I don't know where to find this data. So I need this kind of information in order to track them.
I mean, I expect with that, and probably also Pete's data, that it's undergoing QC, a fair bit of QC first. But I just wanted to make sure that you were both aware of it and you knew who to chase or who should be talking to you. So I mean, that's all work package 2, so I guess it's something to chase up. Equally in work package 5, a bunch of moorings have gone in, or instruments on moorings have gone in. But they're not going to be out for another year or so. So I'm not sure if that's beyond knowing that those are in there. Is that all you need? Because the data is not going to be available or out of the water for another 12 months at least.
Yeah. Well, actually, another thing that is quite important for me, for example, during last campaign that I don't remember if it was Ocean Eyes or Sochic to support it, some data from Alfred Wagner Institute station were recovered. And I mean, in that case, I was able to find this data, and so I was able to connect this data to the system by reading the cruise report. But I mean, I got that information very late. So when the cruise report was eventually published and broadcasted across it was Sochic, Andrew. It would be very helpful to me if I may have a sort of planning of which station are planned to be recovered or deployed, because then I can really go back and check if this data is coming out. Because as you said, most of the case, when you do this kind of delayed mode, let's say collection, you need to apply some quality check, some processing to the data. And then you deliver it to, I mean, the system that you use it to do. In case of the German station, they deliver it to Pangea. But if I know, then I can cross-check, and as soon as they are published, then we can see also in the other system. Otherwise, I'm blind in the process.
Okay, well, that's helpful to know. So I know that Paul Abrahamson has just published his cruise report for the mooring deployment, so I'll make sure a copy of that goes to you. But I think we can probably lean on Pete Davis and Anna for a bit more information there, just so you know what happened and what to expect. I mean, those are the milestone reports, I think, are available for those deployments. But we'll ask them to be a bit more explicit to you.
Yeah.
Good.
And the other thing is just to say, I mean, we try somehow to attend as many other work packages meeting as possible, but of course, I mean, the time is limited for all of us. So time by time, we also miss some of this kind of information. And yes, so if
you shouldn't have to come looking, we should just tell you. It makes
it would be much easier. Yes. Yeah. Yes, Pierre.
Yeah, Antonio, there are two data sets. They are, compilation data set that we just published. Well, Shenji just prepared and published. She published version 1 actually of those data sets. So they are compilations of data set that are already existing elsewhere, right, in the system. And some of the data set are new, but they all have a DOI or links somewhere else. How are you planning, or is there any plan to integrate that within SUSMAP? And how's that going to work? Because
this is a very good question, because I mean we had a discussion in the data management steering committee how to handle this information, because it's important. Let's say it's good to have this compilation, because somehow they went through a new, let's say, processing of validation, quality checks. So it's an updated version of something. And so it's important to have them publish it also in the, in the system, and so eventually in SUSMAP. We are now studying how to, let's say, show a sort of versioning system of this collection. And said so, it's important that we receive this collection as well, because then it will be, we can apply the same, let's say, workflow. So we get it, we publish in the backend of OceanEyes, and then we can see them on SUSMAP. And we need to label in a proper way to get, for example, one thing that we're also thinking is that if that collection is associated to a given paper, then we can use, for example, the paper as an entry point together with that collection to be queryable in the SUSMAP. This is the kind of thing, but we still have to identify let's say, we need to fine tune the way to do that, but it's important to have them in.
Okay, cool.
Yep. And yes, by the way, there will be dedicated cards in SUSMAP, because they are collection in the end, and they are dedicated collection, and so they will be per se. Yeah, we also have the same case for one collection that Sebastian published 1 year ago, more or less. And we just discovered it by chance in Zenodo, and we said, oh, come on, this is important to have it inside, because it's, they applied some further processing, and they are also putting together more data from different platforms for a given area. And it's important for research purposes. So we need to have it. Other question? Good. Yes, let's go dancing. No, by the way, anytime that you have any question on data management, or if you, feel free to ask us. We are here for that. As we said, we designed the work package 7 to be this kind of interface between, the research activity that you're doing in the project and the other stakeholders. So if we get, if we receive the proper information in time, then it will be easier for us to publish and broadcast the different data outcomes, let's say, of the project. And so we can make also more visible the impact that OceanEyes is doing in some communities. IMONET is one of them, Copernicus is another, SUSMAP, of course, I'm in charge of that. Good, okay, guys, if there is no any further question, I would like to thank you for listening. Hope that you find something useful in the presentation. And as I said, we are here for you, so don't mind to, don't be ashamed to contact us if you need support for the data management.
Thank you very much, Antonio, and we'll make sure those people who have outstanding cruise reports or information send it along to you shortly.
Perfect.
Thanks, Antonio. Bye-bye.
Thank you so much, guys.
Thank
Have a
you.
nice day.
Bye.